with you, Asudev. Let me know of it. Let me get some on the same.
So currently preparing for JEE. I mean, that's my primary goal right now. Besides that, I've also finished my university application essays, most of them. My subject otherwise are remaining, but I'm working on that. Besides that, I've shifted gears from IOQM preparation to IOI preparation because I've had a lot more experience in that field, and I think it's a more prudent use of time.
Okay, so what are you as of now taking in physics?
So they're doing, I think they finished magnetism, electricity and magnetism, and now they're starting magnetism and matter, two different separate chapters.
Magnetism.
So?
Have they finished magnetism?
So they finished magnetism as in like the first part of the chapter where they deal with Lorentz force, Biot-Savart law, and those things.
Let me ask you the portion which I'm skeptic of being even touched. Correct me if I'm wrong. There is a field magnetic, there is a field electric, and they are perpendicular to each other. A particle is left at the origin. What will be path traced by the particle? Why I do ask, it's theory to us. And from this theory, we are to get how to solve questions related to maximum displacement of particle when both the fields are present, electric and magnetic. So are you aware of this? Is question number one.
So you're basically referring to the question where there's an electric field and there's a magnetic field. Usually they're perpendicular to each other. And you're supposed to describe the trajectory taken by a charged particle in that field.
Correct.
Those questions have been done.
Those questions have been taken.
Yes, sir.
Okay. So what should be the maximum displacement and what should be the path of trajectory?
Most of the time, I mean, really, those are rather simple questions. I mean, the initial conditions were.
It's simple here. I think you are confusing it with the other one, wherein you have pitch. I'm not referring to the case in which
I am, but that was that wasn't the case of a pure magnetic field, right? There was no electric field in that scenario.
No, you are having pitch. If you're having pitch, in that case, what we do is we check for what is the angle being thrown, and accordingly we look for, as you said rightly, if there is electric, and electric can be either perpendicular or parallel to magnetic, then what is the course of action? What is the path taken by the particle? That is what I'm referring to. And to begin with, I'm assuming that they are perpendicular to each other and you have left the particle at the origin. So could you please let me know what will be the maximum displacement of a particle? You can take the electric field as E, you can take the magnetic field as B, mass M, charge Q. What being asked is maximum displacement of particle. By maximum displacement, I mean what will be the maximum Y or maximum X by which the particle will get displaced.
It's just initially, I mean, okay, actually, I think I should probably correct myself. This specific question was not taken in class. And
the question, I began with the premise that I'm not taking any question. I'm taking theory. It's a theoretical part which will translate to many a question. There are many a question coming, and one I can cite the subjective part of SC Verma per se, wherein he has given you a capacitor and a magnetic field being present and being asked what should be the speed of particle projected so that the particle doesn't hit the other plate capacitor.
Yes, sir.
Those are the places where we'll be using them. Are you getting it?
Yes, sir.
What is this? And second question, which I want to highlight, which is of equal import, is what is pressure? If you have taken a cylindrical conductor, then what pressure will be built at any point on that conductor? Let's say there's a cylindrical conductor which is translating into a current carrying device given J to you. What will be pressure on the wall of this conductor? What pressure will build up on wall of this conductor? That is being asked.
So this wasn't taken either.
These are the two questions which I want to highlight then for this. Okay, dear?
Yes.
Let us draw a frame then quickly. Let us draw a frame. X, Y, Z you can mark.
So could you just hold it for 1 second? I'll just
Sure.
start recording.
Yeah. Visible board.
Yes, sir.
Yes, sir. You can continue.
Let's start with. This is the XYZ field for me. These are the axes that I have taken. There's a particle over here, and this particle is let at that point. Let at that point you're aware of, B will not have any effect on it. B will not be able to produce any field which is not to produce effect on charge which is stationary, being B field, and not be able to apply any force on it, but E certainly is too. E is in this direction taken by me. So what will happen? What will be the first case? There'll be a force due to which field? Due to electric field. Owing to this force, charge will start drifting to the right. Correct? Yeah.
Yes, sir.
The charge started drifting to the right, and that is when B field will come in play. Correct?
Yes,
What
sir.
path? I don't know. As of now, we are not aware of path, but we can insuate, or we will say we can try to make a hunch at least on the path. And what hunch I'm into making is path will be somewhat like this. And what will be the reason for this path? I'm just showing you what direction of B field is there for us. Let's say B field is into the board. Okay. Q positive, B into the board, right?
Yes,
Q
sir.
into V cross B in which direction? Q downward, V cross B. I think this path is justified, right? Yeah. Q into V
Yes,
cross
sir.
B. Q is positive. V cross B will be in which direction you're aware of and keep on changing, right?
Yes, sir.
At any point in time, I show my particle having a velocity V as being shown there. This is V. Okay.
Yes, sir.
This is velocity V. In which direction you will get force is an obvious. Tell me, am I right? If I place force in this direction, Q
Yes,
into
sir.
cross B, that will be direction of force, and in which direction will be electric force as shown. In this direction will be electric force. Please do endorse.
Yes, sir.
Okay, so this is Q, V, B, and this is Q, E. Angle, please. Let us take the angle as theta. This is the angle which I'm referring to, theta. Please do take a good note of it.
Yes, sir.
Okay, now let me know what will be M dV if this is X to me, this Y, and this Z. Then what will be M dVx by dt? Quick, please. M dVx by dt. What will you say it to be? QE minus. Yes, please. QE minus. What will it be? QVB cos theta sin theta.
So,
You can take
yes, sine theta, sine theta, sine
90,
theta.
and this will be 90 minus theta, right?
Yes, sir.
So QVB sin theta, right?
Yes, sir.
Okay. Now what about M dVy by dt? Quick on this as well.
So QVB
M
cos theta.
dVy. So that'll be simple. QVB cos of the angle theta. Agreement, yeah?
Yes, sir.
Okay, please do check. Vibha, is it fine?
Sir, I'm not sure why did we take sine theta. I didn't get it. I didn't get that sine theta part.
Angle, what will be QVB? It is taken in which direction? X direction. That is 90 minus theta, the angle. Do check. The angle, this one, will be 90 minus theta, right?
Yes, sir. Yeah.
So QVB cos of the angle 90 minus theta will fetch you sine theta. Agreement?
Oh, yes. Yes, sir.
Okay, Vasudev, tell me what should I do next? You know that, Vasudev. Come on, help me.
Yes, so now that you've got the forces acting on the body, you've essentially got their acceleration, so you can find their velocity at any period, at any point in time, and as a consequence, also the position as a function of time.
I expect an answer better. Can I expect an answer which is deemed of Vasudev, not the answer which any student is to get me? Come on, Vasudev.
So what are you expecting to find?
I'm
What do
expecting you to get me some equation which you have a deja vu with simple harmonic motion. Something which we can do. Now let me ask you categorically, Vasudev. Can you get a substitution for V sine theta? Can I write Vy or Vx for it? V sine theta. Can you get me an affirmation on V sine theta can be changed by Vy? Agreement?
So you're saying V sine theta is equal to V? Yes, sir, yes, sir, of course, yes.
That is what I'm saying. V sine theta is nothing but Vy, right?
Yes, sir.
So this is to be rewritten as QE minus QBVY, right?
Yes, sir.
And what about the other one? QBVX. Can you play on your hunch now, Vasudev, and get me, or can you preempt what I'm trying to over here eventuate this equation to?
Give me a moment.
Yeah, sure. You have your time. You have your moment. We are aware of Vx, Vy, V cos theta, V sin theta. Will you approve of differentiation of first equation with respect to time? Shall I go ahead?
Yes.
I'm trying,
Yes.
right? No, I'm trying. Yeah. Shall we
I
try?
mean, we would be able to use
What
a
do we
substitution.
stand gain? Basically, what do we stand gain? Let us try. I'm just trying, nothing much. There is nothing which I'm carrying, no baggage. QE 0 minus of QB. And what do we get? dVy by dt. Do check.
Yes, sir.
Do I have a substitution for this?
Yes,
Do I
sir.
have a substitution for this? Yes, we do have. What is that? From here, let us write it down then. md square Vx by dt square is equal to what to us? Minus of QB and then dVy by dt. What is dVy by dt? QB by mVx, correct?
Yes, sir.
So we write over here QB by mVx, which is to get me minus Q square B square by M square all into Vx. Do check, dear. Do check. Nostalgia hitting or not? The final equation.
Yes, sir.
What is this? Yeah. Tell me, Vasudev. Yes, please. Go ahead.
So, but for SHM, we got the first, I mean, the second derivative of position is proportional to the position, right? A is equal to minus kx.
Yes, exactly. What I'm trying to suggest over here is this is not between acceleration and x. I'm not saying x is too simple harmonic motion execution. That I'm not into saying. I'm saying
so basically velocity is performing simple harmonic motion.
Vx, right?
Yeah, so the x velocity is performing simple harmonic
Solution
motion.
for Vx. Let me ask you for the solution now. Can we write, if I'm taking this as omega, what is omega? QB by m. Now write it down. Omega is QB by m over here. This is omega square.
Yes, sir.
What solution? Mathematical solution is what I look forward for. What I can write for it is Vmax, right? Vmax into sine of the angle. Now I'm taking a leaf out of our simple harmonic motion equation. Getting it? Omega t plus phi, okay? Well, what is phi? We call it epoch or initial phase, remember?
Yes, sir.
And what omega? QB by M. Correct, yeah?
Yes, sir.
Help me get Vmax. Omega we know, we don't know phi. We can get phi easily. The particle was initially at rest. Correct, yeah?
Yes,
So
sir.
putting t equal to 0, we get phi 0. What it reduces to is Vmax sine of the angle. Tell me, omega t, right?
Yes, sir.
Help me on Vmax. Fetch me Vmax. How can I get Vmax? Come on, tell me. Someone is to tell me how will I get Vmax? I don't have Vmax. From boundary condition, you can get to know on Vmax. Come on. You know what will be Vmax? You get me what will be Vmax?
Similar to that, but then again.
Shall I help you?
Yeah, that seems right, but my
What is
SHM
A?
is a bit risky
What
here.
is A initial? Is that not known to us? A initial. A initial. Initially, A was only in one direction, right there.
Yes, sir. Yes.
So A initially was only AX, correct?
Yes, sir.
And it was QE by
E
M.
by M. Yes, sir.
I think this is enough a hint to catch. You have Vx, you can get from here Ax, correct?
Ah,
What
yes,
is
yes, yes.
X?
Very good.
Vmax into omega cos of the angle omega t, right here.
Yes, sir.
And initial Ax means t equal to 0, right?
Yes, sir.
And at t equal to 0, what is Ax? Just now we got it. QE
E
by
by M.
Q by M is equal to Vmax into omega. This gets you Vmax.
Yes, sir.
What is Vmax? Q by M omega. And what is omega? You know, omega itself is QB by M. QB by M. Omega is QB by M, correct?
Yes, sir.
So what do we get? Vmax, quickly. Vmax. Substitute for omega, QB by M.
Yes, sir. You get E by B.
E by B, write it down. Vmax is E by B. Vmax is equal to E by B. Once you got Vmax, you get Vx. What is Vx? E by B sine of the angle omega t. Got it, yeah?
Yes, sir.
Okay, you got Vx now, though we are far from what we intend to find. What we intended was, how is x changing? Tell me, what do I do here? Now what? You are aware of it.
Integrate both sides.
Yeah, exactly. Do the integration. Please let me know how is x varying. dx by dt. Substitute for Vx. dx by dt. Integrate. From theta is equal to 0 to theta equal to theta. That means from t equal to 0 to t equal to t. What do we get x as?
So minus cos omega t times E by B omega.
So let me write that down. X is equal to E by B omega is what you have said. Bracket open.
Minus cos omega.
There will be 1 minus cos omega t. How can it be cos omega t, Vasudev?
Ah, yes, yes. 1 minus cos omega t. I always miss that limit.
No. Don't say that. If you'll say that, your mind will make you believe it. And you will
Yes.
be always into doing the same mistake. So this is x, right?
Yes, sir.
And this x, Vasudev, you will endorse is an equation for variation of x for a cycloid. Cycloid, you remember?
So I do remember posing the question in class.
theta is the angle by which, let us say, a cycle turns. Theta is the angle by which one of the diameter of a cycle, which initially was perpendicular, turns, right?
Yes, sir.
And you wish to write coordinate, x coordinate and y coordinate, right? What do we get? You will endorse it, and accordingly you'll get to know, yes, it will execute a cycloidal motion.
So you're only
Now,
considering the x
left, any point in time, it can get disconnected, just a caveat. And thereafter, I'll not be able to connect for the day. Sunday morning, I'm planning to keep at 5 for sure. I will be updating you on it. I can further even today, if possible, after it gets charged, but I'm not into any promises, no promises for this day. I'm just letting you know that E by B omega 1 minus cos omega t is nothing but equation for cycloid. This is x. And how can we prove that? Take a tire with a diameter perpendicular. Rotate that tire. That means let the tire move forward and rotate by what angle? Theta. Is it okay?
Yes.
Then write the x coordinate of the periphery. What we will get? You get r theta plus x cos theta. Will we? I'll draw for the case. I'll draw for the case. No issues. Let me see how far it supports, and accordingly, I'm referring to this. There are no rocket science. This point. Center has moved forward by r theta. Okay.
Yes, sir.
This is theta. Okay. So what will be coordinate of this point? R theta plus x sine theta. Right. R
Yes, sir.
theta plus r sine theta. Right.
Mhm.
And what will be y coordinate? R plus r sine theta. R plus r sine theta. Cos theta, sorry. Cos theta, right? R plus r cos theta, correct?
Yes, sir.
What about this one? R theta minus
R sin theta.
Okay. And this one, R minus r cos theta, right? This is
Yes.
theta. You wish to get this point, right?
Yes.
R minus r cos theta. Is it not same as this?
But that was the y coordinate.
Look. I'm talking of this coordinate, yeah? I'm talking of this coordinate. Yeah, y only. I'm talking y only. I'm talking y, correct.
Yes.
I'm talking y, don't worry. Here the path is this way, Vasudev. It goes this way, okay? And in this case, the path will be this way, okay?
So, but like right now, we're only talking about the x coordinate.
Yes.
And all we know is the x.
Why we will get from here? Why will get from here? Because we have the equation, right?
Yes, sir.
We'll place over here, we'll get y. That is not an issue. Issue is to extrapolate what path you will be getting. Okay?
So,
Here, whatever is y, right? Check over here. Whatever is y is what is x in splitting image with. Check it out.
yes, sir. So you're suggesting that's why the path is kind of flipped 90 degrees?
Yes. Because what you got over here as x, here it is y. What you are getting y over here, you will get what you are getting x over here, you will get over here as y. Okay,
Yes.
you can check that. No issue. That will make it flip the way that I have suggested, but a caveat over here, that is not the maximum distance. Maximum distance will be twice of r, okay? From here we take, correct?
Yes, sir.
R is E by B omega. But when people are to ask you about maximum displacement, then maximum displacement will be twice of r, correct?
Yes, sir, because 1 minus cos theta can go to 2.
Displacement will be twice of E by B omega. Got it?
Yes, sir.
Write that down categorically. Maximum displacement, maximum x that will get deflected by over here. Look over here. Maximum x that will get deflected by will be twice of E divided by B omega. Twice of E divided by B omega. Path trace cycloidical. Thankfully, the cell did support. Okay. Okay, dear.
Yes, sir. Did his feed just freeze for you?
Yeah, Sir? Hello, sir?
No, I don't think he can hear us.
He said his battery was dying, right? I mean, his phone, something was
Yeah, he
dying.
did mention that at the beginning to suspect his phone ran out
I
of
think
juice now.
it turned off.
Let me just WhatsApp him.
Yeah. Hopefully. Is he online or responding or anything?
The last messages I sent were undelivered. I think it's safe to assume his phone ran out of battery.
So, what?
I don't know, say we wait for 5 minutes. I mean, I'm pretty sure he has other devices if he comes back, alright? Otherwise, maybe we can just leave until he sends us a message. So they're not gonna be here. Right, I don't think he's coming back.
So, should we quit the call or something?
Yeah, I mean, he did say he wasn't making any promises. I don't think we should be waiting. If he does come back, he'll send us a message.
He can call us and we can, yeah, he can call us back also, yeah.
Right then. So, bye.
Bye.